Unit 5, we are learning mid-segment theorem and the coordinate proof, 5.1. In this lesson, we do the warm-up first. The warm-up question number 1, what is the midpoint of a segment? And label it as a point M. So we label that midpoint right here. So we label that as a M. Point M is the midpoint. So that gives us AN congruent to MB. So we write that we have AN, segment AN must congruent segment NB. So recall that what is the midpoint? Midpoint is a point that cuts a segment into two equal parts. So midpoint is a midpoint is a point that cuts a segment into two equal parts. So number 2, if AB equal to 10 units, what is AN? The length of AN. So remember, if you have nothing on the top, which means the length of segment AB equal to 10 units. What is AN? So since AB is the whole length from A to B, so midpoint M is midpoint, so AM will be half of AB. So the length of AN must equal to 10 divided by 2, that gives you 5. 5 units. So AN equal to 5 units. So what about NB? So NB equal to MA by definition of midpoint, which we learned from last unit. So by definition of midpoint, we know that if segment NB congruent to segment MA, therefore the length of MB must equal to the length of MA. So by definition of midpoint, we have NB segment congruent to MA. So therefore, the length of MB must equal the length of MA. That is the definition of congruency. Okay? So therefore, we know that MB must equal to MA, and MA equals to 5 units. So MB, the length of segment MB also equal to 5 units. Okay, that's number 2. So let's take a look at number 3 with the question: if AB, segment AB was a coordinate plane, was on a coordinate plane with A at -3, 5. So negative 1, 2, 3, 1, 2, 3, 4, 5 is right here. So that is -3, 5, which is my point A. And point B is at 1, 2, 3, 1, 2, 3. That's my point B. Point B is 3, -3. Okay, if this is this 2 point, we connect them. We got A, B. Okay. And plot a segment. That's the segment. Well, pretend this is a straight line, okay? Because my hand drawing is not that perfect. So determine the coordinate of M, the midpoint. If you can use the straight edge, it's easy to find. Mine is also not that bad. It's right about here. So I think it's about here. Not that bad. Okay. So that point, let's verify what's the coordinate for that. So record that we have the midpoint formula. The midpoint formula told us that M will equal to, the N represent the midpoint. The midpoint. So I think we better use, let's erase it. We better use what? Normally we use a letter N represent a point, because we use the upper case of letter represent a point. So that's the way we name a point. So which equal to x1 plus x2 divided by 2, common y1 plus y2 divided by 2. That's the formula of midpoint. Midpoint formula. Okay, so we use the formula. We just plug in these 2 points. So A is that, B is that. So directly use the formula. We plug in A, x1. We say that is x1. Y1, this is the x2, y2. So you plug in x1, which is -3, plus x2, which is 3, divided by 2. And the y1 is 5, plus y2, -3, divided by 2. So we simplify, we get the -3 plus 3 is 0. So it's 0 over 2, common 5 plus -3 is equal to 5 minus 3, which is 2 over 2. So that's 0, 1. So the midpoint must at here, we label that as an N midpoint, which is 0, 1. Actually, my picture is okay. Not too bad. Okay, that's the answer for that warm-up. So determine AN and BN. So AN and BN, how do you find the length of AN and the length of NB? So we use the distance formula. So what is the distance formula? That is D equal to, the distance is the length, okay, square root of parenthesis x2 minus x1 squared. plus y2 minus y1 squared. So can see that what is my point A? Go back to C. -3, 5. My B is 3, 3. 3, -3 is 3, -3. So this is my x1, y1, my x2, y2. So plugging the formula, that gave me an. So first of all, well, yeah, if we want to find an, I would say use n. So let me erase this one, okay? We directly use n instead of b, okay? So we use n, which is 0, 1. So that's my x2, y2. So square root of plugging 0 minus x2 minus x1 minus -3 squared plus y2 minus y1, y2 minus y1 squared. That gives me square root of, which is negative, negative, positive. Remember, the whole thing inside simplified. We got 3 squared plus -4. Don't forget, it's inside the parenthesis. The parenthesis, the whole thing squared. That gives me 3 squared is 9 plus 4. -4 squared is positive 16. That is square root of 25, which is 5. So an is 5. So what about bn? My b is 3, -3. Go back to C. Yes. So now this is my new x1, y1. So how do I find my NB? Use same formula here. Square root of parenthesis x2 minus x1, which is 0 minus 3 square again, plus y2 minus y1. y2 is 1 minus y1. Remember, everything inside the parenthesis must go simplified first. So -3 squared is 9 plus 1 minus -3 is 1 plus 3 is 4 squared. I'll give you 9 plus 16, which is square root of 25, give you 5. So from here you can see that actually an is equal to nb. So now we have the conclusion an equal to nb. Okay, so that's the relationship between this. So compare the answer with number 2 above. Number 2, what do we have the answer? Yeah, 5 units. 5 units. So that's the same. Okay, that's the warm-up for today. Kind of long. Okay, let's turn to the next page. Fill in the blank. So mid-segment. So first thing, mid-segment of a triangle So what is the definition of the mixed segment of a triangle? It is a segment, that connects the midpoint. Connect two midpoints, right? Connect the midpoints of two sides of the triangle. So that will give us, since in one triangle, how many sides we have in one triangle? In one triangle, we have three sides. 1, 2, 3. 3 sides. So we have 3 sides. So each side you have a midpoint. So we have 3 midpoints, which means this congruent, and this congruent. So 3 midpoints, let's label that X, Y, and Z. So if we have 3 sides, we connect all 3 midpoints together, which gives us 3 mid-segment. Okay, so in one triangle you have 3 mid-segments. Draw and mark a triangle ABC with mid-segment that is parallel to AC. So XY is parallel to AC. This XY parallel to AC. So is AX equal to XB? AX, XB? Yes. Is BY equal to YC? BY equal to YC? Yes. So is BX equal to BY? BX equal to BY? Not always. Look at this. This is 1 tick mark. This is 2 tick mark. So no. Yeah, sometimes. Not always. Okay. We said not always. Sometimes. Not always equal. Right. So it might be equal, but if I mark different, they are different, so then they are different. Okay, if you tell from the mark, they are not. But sometimes they equal, but in here, since we mark, they are not different, so they are not equal. So I say maybe. I use no, they are not congruent, because I mark they are not. Unless you are special triangle, all side congruent, so this might be. So, but in here, since I mark different, so they are not congruent. Why not? Because it's not always, right? Because triangle ABC, is not necessary and equilateral triangle. Triangle or an isosceles triangle. So if the triangle is isosceles, this angle, this side congruent that side, then this will be equal because all 4 segments here are congruent. Or even more, if this triangle is an equilateral triangle, so all sides congruent, all 3 sides congruent, so all 3 half sides must be all congruent. So only when the triangle is a special triangle like equilateral triangle or isosceles triangle. Otherwise, these 2 sides will not be congruent, okay? Next one, mixed segment theorem. So this is a theorem. A theorem said the segment connecting the midpoint of 2 sides of a triangle is parallel to the 3rd side and is half as long as the side, which means if this is the midpoint, which means BD congruent to AD and BE congruent to EC. If that is this, midpoint, you connect to midpoint, you have a mixed segment by definition. Then if this is a mixed segment, then this line must parallel, and then this mixed segment is half of the base, half of AC. So that's the theorem. We call that mixed segment theorem. So if we write the equation, the mixed segment will equal to 1/2 of the length of third side. So that is also, if you can write a symbol, is the length of BE in this case will equal to 1/2 of length of AC. You can also say that the AC, the length of AC in this case will equal to double 2 times BC, DE, 2 times BE. So that's the equation for mixed segment theorem. Let's do one example here. So find the example 1, find UV and RS. So look at the picture. UV is right here. We are trying to find UV. So how do you find UV? Look. Since here you see this equal that, so obviously the point U is the midpoint of SR. And the point V, look, SV equal to TV. So, which means the point V is the midpoint. So you connect these two, the length here, this must be parallel to this side, and this length is half of that side. So by mixed segment theorem, we know that UV equal to 1/2 of RT. Given RT is 90 inches, so we plug in 90, UV equal to 1/2 of 90. So that is 45. So what's unit? Don't forget the unit. So it's 45 inch for UV. So how do you find RS? So look at the RS, let's use different color. The RS The green one. So RS is where RS. Okay, the RS here related to this one. Since this is the midpoint of this one and V is midpoint of ST and W is the midpoint of RT, because you can see the tip mark are the same. So this by definition is the mid segment of this triangle. So therefore the length of that must be half of that. So you have that WV will equal to 1/2 of RS. Since you are given WV, so you can say, okay, my RS is equal to 2 times WV. Then we plug in that 2 times WV are given 57. That gives you 114 inches. So the answer for RS is 114 inches. Mid segment theorem. Okay. So is RB a mid segment? RB, look at the RB. Let's use different color for that. R is here. V is here. So you connect R with V. Since the R is not the midpoint of any side, so the answer is no. R is not the midpoint. R is not a midpoint of a side. So by definition, you need to connect a midpoint, 2 midpoint, connect together, you get mid segment. So since the V is midpoint, but R is not a midpoint, so RV is not a mid segment. What else do we know about that? Okay, notice that the UV actually congruent to RW. This congruent to that. So we can conclude that UV actually congruent to RW and also congruent to WT. And we have VW congruent US and congruent UR. Yes, because that is, let's change the color. So VW congruent to this one and congruent to that one. VW congruent to US and UR. Okay, that's the example 1. Let's do example 2. Example 2, given triangle GHJ and the ABC are midpoint. So if ABC are midpoint, so we can mark A, B, and C midpoint. So this is equal that, this equal that, And of course, this will equal this. Midpoint, cutting half. So, given that AB is 3x plus 8, we mark over here. And given that GJ from here to here is 2x plus 24. 2x plus 24. That's given. So we are looking for what is the length of AB. You're looking for the actually length of AB. So what's the relationship between AB and the GJ? Because by definition, given you connect two midpoints, you get the one mixed segment, and by definition, by the theorem, mixed segment theorem tell you that your mixed segment will be half of GJ, or GJ equal to double of that. Okay, so we write the equation for that. The AB is equal to 1/2 of GJ. Color change. So AB, we plug in the given information. 3x plus 8 will equal to 1/2 of parenthesis. GJ is this one, 2x plus 24. So simplify. 3x plus 8, we multiply this in here and in there. We do distributive property. That gives us 1/2 times 2x is x. 1/2 times 24 is 12. So 3x plus 8 equal to x plus 12. So we move this to the other side. Doing so, we minus x both sides. That gives us 2x. Put this down, equal to 12. And minus 8, you got 2x equal to 4. Divide by 2, x equal to 2. So you have x equal to 2, but you are not looking for x. You're looking for what is the length of AB. So you plug in AB, so length of AB equal to 3 times x. X is 2, and plus 8. So that's 6 plus 8 is 14. So your AB equal to 14. Check if you have unit. No. So 14 is your answer. That's example 2. So let's take a look at example 3. This one is a little bit more challenging, okay? Challenge question. So let's read the question. Use the diagram above, like this. And so where A, B, C are midpoint of the side, see if you can find the parameter of AB, triangle ABC. When you are given that, okay, you are given GH, the whole thing, GH is from here to here, is 12. And HJ from here to here is 10. And from here to here is 5. The whole thing is that. Okay. Use the diagram above and the midpoint of sides to see if you can find the parameter of that. Okay. So the parameter of that, parameter of who? Parameter of this guy. A, B, C, A, B, C. This triangle, A, B, C. How do you find A, B, C? Look, the A, B is the midpoint, right? Given these 3 points are midpoint. So connect together, you got 3 mixed segments. These 3 are mixed segments. So by mixed segment theorem, that this side will be half of that. So you are looking for parameter of triangle ABC. That will equal to the length of AB plus length of BC plus length of AC. And you know that AB is half of that, right? So we know that AB's mixed segment will equal to half of GJ. And the BC is also mixed segment. BC is half of GH, 1/2 of GH. And the AC is also a mixed segment, will equal to half of that, half of HJ. Since we are given midpoint, so this is equal to that, half, and this equal that, and this be cut in half by C. Okay, so we substitute this in here. So what do we have? We have 1/2 of GJ plus 1/2 of GH plus 1/2 of HJ, and substitute the number in here. 1/2 of what? GJ is 5 plus 1/2 of GH is 12 plus 1/2 of HJ is 10. So that gives us 2.5 plus 6 plus 5. That is 13.5. So 13.5 is the parameter of triangle ABC. So that's the answer. P parameter equal 13.5. That's one way you can find. So let's take a look. This actually is half of this plus that. So AB plus BC plus AC. If we factor this all out, let me use the red one. So from here, we discover that. So parameter of triangle ABC will equal to, we factor all 1/2 out. We have GJ plus GH plus HJ. That happened to be 1/2 of GJ plus JH plus HG, which is the parameter of triangle G, J, H. So that's what we discover from this question. So the perimeter of the smaller triangle here, which is formed by 3 mixed segments of triangle HGJ. So the perimeter will be half of the triangle HGJ. Let's see the next page. Okay. Coordinate proof. Okay. How do you prove with coordinate? Coordinate proof involves placing geometric figure in a coordinate plane. Okay, so you make the proof easy. To make the proof easy, so set one vertex at origin. So you use the origin 0, 0 is one of the vertex. Use the x or y axis as one of your side. Okay, x, y. So let's see, get the point. This is the example. Okay, 0, 0 and 0, B. Let's say this is a B. Okay, so point B, point A. So here is 0B. And the other point here, we said point C. Point C is here, AB. X equal to A, Y equal to B. So you connect this one, you get a rectangle. This is a rectangle. Alright. So that's A, 0, which is your point D. From this picture, you can see from A to D, this length is A. From C to D, this length is B. And this is B. This is also A. Okay, so if you have that point, 4 point, okay? So how do you find, what are we looking for? We are going to prove a rectangle, length A, which is this, and width B, And this is a rectangle, so you can mark one of the angle is 90 degrees. We are going to prove that this is a rectangle. We don't know this is 90 degrees yet, right? So we don't mark that. Erase it. Okay. We don't know that yet. We try to prove, okay, we try to prove that. How do you prove a figure is a rectangle? How do you prove it? First of all, you have to prove this. The length BC must congruent length AB. And then you have to prove BA is congruent to CD. Have the same length, okay? So length equal segment congruent. And then you have to prove this slope, this line, the slope of this line and slope of that line. Actually, they are 90 degrees. So the slope will be opposite reciprocal, 90 degrees. So you need to use formula to find length, two lengths here, and see if they are equal, and two lengths here, and see if they are equal. And then you prove these two lines are perpendicular. That's what you need to do. So let's start from the length. Okay, how do you find the length? To prove this, you have to show that AB is congruent to CD. Okay. Instead of you to show this, you have to find the length equal. So let's check if the length is equal. So let's find AB and find CD. So how do you find AB? The length, use this distance formula. A is here, B is here, so use one minus the other one. So you have, okay, A, B. So x minus x, you have 0 minus 0 squared plus 1 minus y, which is 0 minus b, or b minus 0 squared. That gives you square root of, this is 0, then this is b squared. Negative b into square equal to b squared. Square root of that is b. So your length is b. So let's check CD. Square root of, plugging that C and D. So x minus x, which is a minus a squared, plus y minus y. So we don't care who minus who. So we use b minus 0 equal square. And that gives you, this is 0. So b minus 0 is b squared, and that gives you b also. So since you have b here equal to b here, so which means AB is equal to CD. That gives you segment AB by definition of congruence. AB must congruent to CD. So we prove one side congruent, so you have AB congruent to CD. Now we have to prove these two congruent. So we use this side. We find the length of BC, which is square root of 0 ABB. I use A to minus 0 because x2 minus x1, A minus 0 squared plus B minus B squared. That gives me, this is 0, so you have A squared. That gives me A. Then we have to find AD. AD is distance formula will equal to A and D. I use A minus, so B minus A. So you have A minus 0 squared plus 0 minus 0, which is 0 squared. That gives me A squared, this is 0. A minus 0, A squared, that gives me A. So they both A. So their length length equal, so BC equal to AD. So that gives me, by definition of congruence, BC must congruent AD. Okay, so we prove this congruent this. So left over, we need to prove this angle is 90 degrees. To do so, we have to prove their slope are opposite reciprocal. So let's move down. How do you find slope? Let me use another color. Find slope. We need to show the slope are opposite reciprocal, okay? Okay, how do you find the slope for this line AB, slope equal to the slope. How do you find slope for AB? We know that AB is a vertical line, so the slope is y2 minus y1 over x2 minus x1, which is y2 is b minus 0 equal to 0 minus 0, okay? y2 minus y1, b minus 0, x2 minus x1, 0 minus 0. So give you b over 0, which is undefined. So we know that vertical line are undefined. And then we have to find the slope of lines AB. And the same formula. So y2 minus y1, which is 0 minus 0, x2 minus x1 is a minus 0, which gives me 0 over a. And 0 over a is 0. So this is undefined, this is 0. So they are opposite, reciprocal. So we know that, yeah, A, okay, A, B over A. Yeah, because 0, B over A, B, C, D, B, A, B, C, D. Okay, so this is AB. Undefined. So if one angle is 90 degree, all angle must be 90 degree. So since the 0 and the b over 0 is, this can see, you can see this is 0 over b. So they are opposite. So opposite, reciprocal. So we can say that perpendicular. And perpendicular means they are 90 degree. So this angle is 90 degree. Therefore, we can say the ABCD is a rectangle. We're done. That's the proof. It's kind of long. I hope you understand. Okay, if you need, you can go over that again. Maybe you need a little bit time. So how do you know? How do you show it is a rectangle? So let's write that down. How do you show that it's rectangle? First of all, you have 90-degree angles. 90-degree angles because you have two slopes. Are opposite, reciprocal. And secondly, you have opposite side are congruent. So that gives you a rectangle. Two pair of opposite side. Okay, that's today's lesson. Thank you.